Eugene, what happens next? We have a negative slope, negative area. So I have to go back to my cheat sheet. Negative slope, negative area, negative slope, negative area, parabolic going down. So it goes down like this. And what does it go down to? What's this area? 1/2 base, which is 2, times height, which is 36. So what's the area?
36?
Yep. So it's 36, so 36 plus 9 is 45. David, what happens next? We have a negative slope, positive area. Negative slope, positive area, parabolic up, right?
Yeah, up.
Okay, and tell me what it goes up to. What's this area? You know how to do area of a trapezoid, you guys? 1/2, 76.5 plus 4.5 times the base, which is 4. $162?
Yeah.
And it goes like this, right?
Right.
So if it's 162, what does it go up to? Did somebody else get 162? You guys?
Yeah.
Yeah.
117?
117.
Yeah.
Then Larson, what happens here? We have a positive slope.
It's just a horizontal, or not horizontal, sloped line going upwards.
Up, right?
And it goes up.
4.5 times 2, 9.
9.
The area,
Yeah.
right? Okay, so we go up 9, so now we're up to 126. And then DJ, what happens next?
Diagonal line going downwards.
Right, and hopefully it goes to 0, right? Well, let's check. What's the area? 31.5 times 4. What does it turn out to be?
126.
Great. Make sure your lines and curves look different.
Yeah.
What's the maximum moment? And we didn't put units. Isn't this fun? So maximum moment is between the 3rd and 4th section, right, of 126. You guys have a test or a quiz in physics right now?
Test in math.
When's that? Later.
Later today.
Okay, I'm going to pull this up. Now let me answer the why. I know could I answer the why question?
Yeah.
Why? Okay. So, let me just show you that in the rest of, first page of this is an awesome book. I know civils are going to get it, and mechanicals you're going to see it too, and arrows. It has a whole bunch of shear and bending moment diagrams in there based on what the loading pattern is. It's really cool. Do you need it? No, you don't need it because you know how to do them now. You know how to do them all graphically. And at the end, I put in how to do it mathematically if you want to. And I'm going to show you an example. So on this let's do this problem. So if I wanted in section 1, mathematically, if I wanted to do it mathematically, actually, you know what? We're not going to do that first one. We're going to do the one you're asking me about with moments. let's do this problem. And we're going to do section 2 instead. And you'll see the full math for all of them, but I'm going to draw it. So section 2 has a distance, it's between 5 and 10 feet, right? 5 to 10 feet. Is everybody following me? Everybody with the right problem?
Yes.
I'm doing section 2. So I'm drawing. Here's the left side. And this is 5 feet. And at 5 feet, I have, what's on the left? 1,800? I have 1,800 pounds. And I have a concentrated moment of 1,000 foot-pound.
1,500 pounds.
And 1,500 is coming down, right? And then this distance I'm going to call x, because it ranges in this area. Is everybody good with that? What I'm trying to calculate is I'm trying to calculate the shear and the bending moment anywhere in here. Okay? Hang on a second. So it depends on your sign. So this is point C, because I call it C because that's where I'm cutting it. My sign convention is I draw my V down, and I draw my moment like this. This is the convention in statics. At the cut, to draw the V going down and the moment. So whatever I calculate for V is what I'm going to show in my shear diagram. Whatever I calculate in my moment is going to be shown in my moment diagram. You may, in a future class, see a different sign convention. So now, let's do the sum of the forces in the Y. Equals 1,800 minus 1,500 minus V equals 0, and V equals 300 newtons, pounds. By using a negative V sign convention, it gives me the actual force that I'm following when I go up. I go up 1,800. I come down 1,500. I'm left with 300, right? When we drew the shear diagram, we went up 18, down 15, and we got a 3. The only way I can get a V value following this is if I use a convention that's putting V in the negative. Something minus V gives you the same units and the same sign as the something. If I put a positive in and I subtract V, V becomes positive. If I put something in that's negative, subtract V, V becomes negative. So this sign convention is chosen so that I can follow my forces. Everybody got it? Moment is positive though. And the reason why is because when you go from the shear diagram to the moment diagram, it's very helpful to have when you have a positive area, to have a positive slope. But if we had an M going in the other direction, in the negative, we would have got an opposite sign. So now let's do sum of the moments about my cut. 1,800 times 5 plus x negative plus 1,000. 1,500 times x positive plus m equals 0. Notice that here that 1,000 is positive, but because I'm using a positive sign convention for the moment turns out to be the negative of this. So what's 1,800 times 5?
9,000.
40, what is it, 96? No,
9,000.
thank you. 9,000 minus 1,800x plus 1,000 plus 1,500x equals a negative m. So m is equal to
300x plus
300x plus 800. See,
8,000.
is it plus? Yeah, see, I don't like this. So if I'm bringing everything to the other side, so this would be a negative 8, this would be a positive 8, this is a negative 3, a positive z. The moment turns out to be this. So when we plug in the x value at 0, when x is 0, the moment turns out to be 8,000. And sure enough, there's our moment of 8,000 at that point. When x turns out to be 5, does it go to 5? Yeah, another 5. When x is 5, 5 times this is 15, it turns out to be 3. So depending on the sign convention that you use, that's what determines whether it's positive or negative. So for the ease of drawing, it's great when you see 18 going up to go up. When you see 15 going down, you go down. The only way you could draw your picture this way is if you choose this sign convention. If the sign convention had V going up, what would this picture look like? It would be a flip of it. It would be flipped. So when you go up 18, you go down 18, which is weird. So that they prefer the sign convention of V going down. And the moment being positive, because it's really nice to go from a positive area to a positive slope. But the only way to keep the same sign is if this is a positive, which makes this guy the opposite of that. So when you have a concentrated positive moment, what do? Go up or down? Concentrated positive moment, you go down. So that's the reason. But you may see it flipped. I remember going through the school, I saw it flipped two times. So I learned it in statics, and you learn it with this way. And then I think strength of materials, it might have been flipped. But see, that might have been, that was the 80s. So long ago. Hopefully they got it right. Nobody's flipping anything for you. But I have a strength of materials book. I could go look and see. So I did all this math for all the problems. You have a choice. You can do it by math or just do it graphically. The key is